I saw this question on YouTube. I have a different way to do it, so I wanted to share with you. Now, I start with the substitution. Let t be 1 over x. So x is equal to 1 over t. Now the integral has been changed to sine t squared, right? Times t squared. And dx will be d 1 over t. And it's from infinity to 0 now. So I can start with by parts, right? This is u, this is dv. So this one is equal to uv, u times v, right? So this one time sine t squared from infinity to 0, and minus v du. V is this, right? Du is equal to cosine t squared times 2t and dt. Yeah. This one, when this one sine t squared over t, I can multiply t and t squared, isn't it? When t squared goes to 0, this limit is going to 1. And this goes to 0. So it's go to 0. So when t goes to 0, this goes to 0. When t goes to infinitive, that's a 0. So the whole thing is a 0. And minus 2. T cancel out, right? 2. And cosine t squared dt. Correct? Yes. Now, I change it minus to plus, and then I switch the order, right? This becomes this. Yeah, see? Switch this one, change the sign. Now, since this is an even function, so this one could be written as from minus infinity to infinity, and cosine t squared dt, yeah. Now, I change this one to complex number. The cosine t squared could be written as e to the I x squared, the real part, right? The real part of this one is the cosine t squared. T, yeah? Okay. And also that cosine negative t squared is equal to positive t. For cosine, a negative positive is the same. So therefore, this is also equal to the real part of exponential negative I t squared, right? So the same thing. So this one is equal to the real part of exponential negative I t squared, yeah, dt. That's correct. Then this one equal to the real part of the integral, and e. This I can write as a negative square root of I times x squared. So this one is equal to this, isn't it? And dt, I can write a d square root I x over square root I. What I want to express is this. Well, the whole thing becomes the real part of 1 over root I integral exponential negative root I x squared d root I x. So this is the Gaussian integral, right? Exponential negative something square d something is equal to root pi, right? Root pi, yeah. That is a Gauss integral. So the whole thing becomes the real part of root pi over root I. So the root pi times the root, a real part of a 1I. Okay. So this one equal to pi times the real part of I to the negative half. Well, this is equal to root pi times the real part. I is equal to E I half pi, right? Negative half. So this is equal to root pi, the real part of e to the negative I quarter pi. Yeah, this is equal to root pi times the real part of this one is a cosine, right? Yeah, cosine negative quarter pi. Wow, this is equal to, wow, finally I got it answer. Okay, that is, I think it's as easy to do it by using the Gauss integral, right? We can avoid the many sophisticated integration. Okay, thank you.